Good morning, everybody. My name is Dustin Smith. If this is your first webinar that you've been joining in, I'll be teaching some just little tips and tricks through these webinars. We've been getting more focused in on the topics of them, a little less broad, thanks to a lot of feedback from you guys. If this is your first time, or if it's your multiple time that you've joined us, we talk about the chat box a lot, where Dan is able to answer any specific questions you guys have, or if it's a little more complicated to answer over the chat box, we'll be able to contact you guys afterwards. So if you guys want to find that chat box, if you go to the bottom of your screen, should be a little pop-up window and you can see the chat box. Last time I told everybody to go in there and say hi to Dan. Feel free to do that again. Dan just said good morning, everybody, if you guys can find that. A lot of familiar names on here and some that I haven't met yet through training or inspection projects, so welcome. This webinar might be a little shorter than the other hour-long ones, but there's a lot of good information that could generate some questions and new processes for you and your team. And also I want to mention, and I'll mention it a couple times, that we have a free little mini webinar next week on building the right touch probe for your next inspection project. Even if you don't have a touch probe, it might be good to tune in and see the possibilities of a touch probe that can get added to your MicroView at any time. So let's jump into it. I noticed, if anybody noticed on the pre-slideshow, I forgot to change the July to August. That was a funny little thing that I noticed, but let's jump into it. I want to do a quick review of last month's webinar. We talked very broadly about GD&T and what the MicroView can do while measuring GD&T, all the different buttons, icons, tools to use, the features that it shows with guard bands. You can see in this window if we were talking about circularity, what tools to use, what you see in your points view, how to analyze the GD&T, because some example like this, circularity, it's great, it gives you a readout, but it really doesn't tell you where it's out of circularity or the true shape of it unless you really analyze the points view and all that kind of stuff. I do have the recording from that one if you guys want it. I know a bunch of you requested it and I sent you the link. And also at the end of September, I'll be doing another webinar strictly on true position and going through real examples of parts and blueprints that are calling up true position, how to measure it, how to set your system up correctly, and the best ways to export that data. I will put the offer out there. If any of you do have parts with true position callouts on there and you're able to send them to me at ATI and I can use them as real life examples on the webinar, feel free to email training@atiquality.com and we can arrange the shipping and all that fun stuff to be able to use those examples. We also talked about GD&T and using touch probe, the option that it's a little more complicated than plug and play, but it is basically plug and play, that if you are able to get the attachment for touch probe, our service guy comes, plugs it in one day, enables all the information and connectors, and you're able to start measuring with touch probe and vision. We'll talk a little bit about that today. Like I mentioned, at the end of September, we'll be talking about true position and all the different options with material modifiers, datum bonuses, what kind of feature it is. We're going to go real in depth on that. So remember to sign up for that and tell all your friends. We also talked about identifying GD&T and what you need to do to kind of battle plan to measure the GD&T. Here's a quick example of step one is find the datums on your part and then highlight any true position, circularity, any of the GD&T callouts, and then find dimensions that influence any of that GD&T. So you're set up for success before even putting the part on your stage. And we'll go through a lot of this at the end of September in more depth. We also talked about reporting through MicroView. the different options that you can put your company logo on there, your address, your company name, and it looks real nice, and it's so professional looking that you can send it to your supplier or customer. Many different options in there. We talked about exporting GD&T. We talked about the different forms of the Excel file that you can get out of MicroView Inspect. So if there's any questions on your data not looking correctly when you export it, feel free to email us and we can help you out of finding the best option there. And we talked about how we take that export out of MicroView Inspect onto an Excel sheet and how we are able to populate our inspection report. So if you send us parts to ATI, if you need a third party to measure your parts, or the parts are larger than your MicroView, or you need touch probe, whatever it might be, you can send it to our team and we'd be able to generate this report for you so you can get all the information that you need. I'll be talking a little bit later about a couple specials we have running on discounts to help you guys out if you guys are overloaded with parts, because you guys are back up and running after, you know, if you guys had any shutdown with everything in COVID, we're here to help for you. I also talked about custom blueprint reading the program training. We've been getting a lot more requests of, I know how to use the MicroView, I know how to read blueprints, but I'm having a hard time applying what I know about the blueprint and what I know about measuring and getting my parts fully programmed with the GD&T. So we've been going on site to customers and just sitting down with the operators and the programmers with their parts and their prints and training through actually creating programs and learning and customizing it with your inspection project and processes. So if this is something that interests you, you guys having difficulties with this, email training@atiquality.com and me or Dan will be able to get in contact with you. It is nice because it's specific GD&T training to your parts and your inspection process. And also it's a bonus that you get to save any program that was written during training. So it's win-win right there. And we've been doing a few webinar training classes. So we'll do basic and advanced training through WebEx. It's nice because, you know, your team can be at home in their own offices. You're not paying for travel for us to come out to your facility. It is a little limiting because we're not on your machine, but it's still great information to get your operators up and running. So let's talk about what we're going to be covering today. I want to talk about streamlining your programs, a thing that we've been calling skeleton programs. We'll get more into that. We'll talk about file paths to keep your programs safe and organized, and also where your exporting data goes to. We're going to talk about drop-down lists, something that we teach in advanced training, but seems to get forgotten about, so I'm going to share a little bit about that and touch on sharing programs between machines. Through all that, we're going to talk about order of taking measurements. One thing I want to hit on is getting your semi-automated programs up and running as quick as possible. Not everybody has fixturing. Not everybody has, not everybody has the ability to write fully automated programs because the part isn't on the same spot on your stage every time. So I want to talk about that. Not following the bubbles on your blueprint. What I mean by bubbles is the numbers on your blueprint. Sometimes they are nice in order, sometimes they're not. So we're going to talk about all that kind of stuff, vision or touch probe first, and then we're going to touch on some advanced features that I've mentioned in other webinars, but kind of want to go a little more in depth in a couple of them, like auto-generate drive points, setting permissions, group tolerancing, and outlier rejection. I got the survey that I sent out after last month's webinar. A few people were asking more about outlier rejection, so we're going to get into that today. So streamlining your program, getting organized before even looking at a part. I've said this multiple times with highlighting your blueprint. I've talked about this with, you know, finding your datums, all that kind of stuff. So even before looking at your part or blueprint, one of the good things to put into practice, if you don't have it already, is have efficient file paths. This helps you knowing where your programs are knowing where your data is going, know where your work instructions are, and are your programs safe. In the file path that I'll show you here in a little bit, I'll break it down into all the folders that I recommend using, and it's not going to be exactly what your company can use or the process that you have, but if maybe there might jog a little idea that might be able to have your file paths a little more efficient than they are. I'm going to talk about drop-down lists. Stop typing so much. When you guys have a program, if you guys are typing username, if you're typing in part number, if you're typing in lot number, whatever it might be, every single time you run the program, there's some drop-down lists that can help you out. And in all that, we'll talk about a basic skeleton program. What I mean by skeleton program is, are you doing the same steps in every program you write? Are you creating the same, user input, the same sample number, a bunch of different things that you can just have a skeleton program that you open up, save as your new part number, and all that information that you normally type in every single program will be there ready to go. And I'm going to build one of those today for you and kind of teach you a couple other things that you can add into that along the way. And on that subject, it's like, what are your constants? What are the same things that you have in every single program? And what are you currently manually doing right now that can be automated? So I'm going to show you a couple codes that you can type in to text and prompts to help you out, that you don't have to manually type those type of things. And then I'm going to just touch a little bit on sharing programs. Been getting a lot of requests on, can I send it to my customer? What's the adjustments that I have to make? So I want to talk about that a little bit. So let's jump into it right here. I'm going to go to my Inspect software. You guys are very familiar with this software. So this is my Inspect software. I'm on the demo version. This is the offline version. If you join my other webinars, you've heard me talk about the offline version and the possibilities to offline program with that. If you haven't heard about that before and you're interested in being able to program in your office or at home, give us an email and we'll be able to help you out there. So before we get into my Inspect software, I want to talk about file paths. So I'm going to come over here to, if I can get over to my desktop here. Too many screens, right? All right, awesome. Here's my desktop. So creating file paths. Most everybody is on a shared drive. If you're not on a shared drive and your computer's not on the network, maybe have a folder on your desktop and skip a couple of these steps and just go to microview. But what we normally like to do is we have a shared drive. And in our shared drive, we have different options here that are, we'll have our procedures, so any calibration procedures, microview procedures. We have our CMM, so all of our programs go into the CMM, calibration certs, and so on forth of roundness tester and contracer. But so I'd go on the shared drive, create a microview folder, and inside my microview folder, I have a drop-downs list folder. So all my drop-down lists that I create, and we'll talk about that here in a minute, are all safe in one folder. So we'll be able to do all that in there. Next, I have an inspection data. So when I set up exports in my microview program, all my inspection data is going to one place. So I don't have one folder that's really messy with all my program files, all my inspection, so kind of separate everything you have going on into different folders. Right here is I have a master program folder with restricted access. So this is good if you have a couple programmers in your facility and then you have operators. And when we get to permissions, you'll see how we can lock down the programs at that level. But also when I program something and I make sure that it's a really good program, pretty bulletproof, has all my exports going, I'll save it in my master programs file, just in case in the regular program file, if something gets adjusted or if it gets deleted, whatever it might be on accident, I have my master programs file with a password protection that IT probably can set up for you. And then in my programs file, I'll have a folder for each one of my programs here. And then also down here is I have my skeleton program, which we're going to talk about here in a second. And this is nice because my skeleton program, I can right click, copy, and when I paste it, I'm able just to rename this to my new part number, whatever it might be. And then inside there, I have my skeleton program that I could rename to my part number. So this is really nice because then my skeleton program is always there. I can copy and paste it and create all my programs from there and so forth. So talking about next is drop-down lists, which we're going to talk about where you can enter a drop-down list. If I'm creating a skeleton program, so some of the things in my skeleton program, I'll have, if it's a fully automated program, I'm always clicking my recall repsys to make it fully automated. So next I would probably put in, you know, say it's my part number. And then next would be lot number. And a few other options there. And like I was saying, the more that you're typing, we'll be able to get into some coding of what we can, so we don't have to go in and always type in the new part number. Because if I right click on this text and I edit the text, you know, my next part number might be this part number. But one of the things that I want to talk about jumping into these skeleton programs is different options that we have for codes. Like I said, stop typing so much here. I'm going to skip through all these here. So there's different coding options that you can do with your text and some of your prompts. This is nice because every single time that you run the program and whatever program you're writing in your skeleton program, it'll draw out information for you, so you don't have to type that. If you and your team have to sign in to like a Windows user or a computer name, you can type in these codes in the text, and every single time that you sign in to your computer, it's going to pull whoever signed in and be able to export that. So on your report, you'd be able to see that Dan signed in or Zachary signed in or Dustin signed in to the computer, and then you would know who ran that program or who was operating that machine at that time. If you have multiple machines, putting this code right here, the $ serial number, $, is every time you run the program and you export that data, it'll tell you which machine and what serial number that was ran on. This is really useful for customers that have multiple machines, because then you're able to track that this part was measured on machine 2, this part was measured on machine 5, whatever it might be. So you can keep track and you can report that information. Some of the other options are inspect user. So you can report who signs into inspect. So when we talk about setting up permissions, you're able to have, if you have an open computer that you don't have to sign in as a user on the desktop, you can have it where you need to sign in to use inspect. So when you go to open up your software, it'll pop up with pick your user and you have to type in your password. And then each one of those users are available to be assigned a different user group with different permissions on there, which I'll actually go through the steps of being able to set that up. It's really useful to, if you have one programmer and you want your operators not being able to save over or overwrite a program, because then it's safe, your programs are safe. No new user is actually accidentally using different lighting options that you don't want to use because you've gone through the trials of writing a fully automated program that's really, really accurate. and repeatable. Some of the other options here are file name. So when I went and typed in my part number, my program is most likely going to be my part number. It's going to be named my part number. So when we make our skeleton program, we can just put in file name, and that's going to pull whatever my file name is into that prompt, into that text. And when you export it, you'll be able to see what that is. So if it's your part number, you don't have to type in your part number every time that you program a new part or whatever it might be. Path name, you can basically export where the file was open. Great to see if programs got moved. So all of a sudden, if you're programming or you're running parts and your parts are not exporting or your data is not exporting to the right location, this could show you if the program file got moved. Modify date and time. This one surprisingly has been coming up a lot more and more. It reports the last time the program was modified. So if you're having, I'm going to use this for example, a customer that we have is in one state in the Midwest, and they have machines in Colorado and Texas. So they're programming at their machine in the Midwest and then sending those programs to Colorado and Texas. A couple months down the road, all of a sudden, those programs are not working correctly, and the main programmer is not there to physically fix the program or, keep watch over it. Having this modified date time in there, when you export the data, you can go back and track to see when the last time that program was saved. So if you created it on August 26th, it'll be August 26th, 2020. It could go for a year, and then all of a sudden in a year, you'll see that that export data was changed to, July 13th, 2022, whatever it might be. So it's a good way to track, and then also it timestamps it, not to get anybody in trouble, but you could see to the time when it was modified, and if you have your inspect user being exported to, those two are tied together. So you can have a nice conversation of why not to modify programs. Cycle count. Honestly, the only reason that I use cycle count is if I'm running time trials on a part, and it'll just tell me, if I go to tools, or actually not tools, let's go back to our inspect software. If I go to Playback and I run cycle, I could have my program run indefinitely or a fixed amount of times. So if I was doing time trials between Generation 2 machine and the new Generation 3 machine that just came out for MicroView, I was running time trials and it showed me how many times it ran, and I did the timestamp on there to show you. Just a little funny thing is this indefinite one, if you have a program with a nice fixture and you guys have a new customer or supplier coming in touring your facility and you want to show off your equipment, you put that program on that's fully automated and click indefinite and click OK, that program will just run. And so when that customer walks through your quality lab, you'll kind of be showing off the machine and showing it what it can do on there. So it's a little side note there. So building our skeleton program and knowing the text, the codes that we can pop in, if I come up here and I save this program as my part number, and then in this text prompt, if I edit the text to be $, file _ name, and if I right click or hit F4 on that, I can export the text and labels. So if I rename that to part number, now in my exports, it's going to export part number, and then it's going to pull what my program name is, which is my part number. So now every time that we open up the skeleton program and go to program a new part, we don't have to come in here, edit text, put in our new one. As long as we save our program as the part number, it's going to pull that data and change whatever that file name is. It is kind of nice too, because if you go into your program, say you go from Rev B to Rev C, and you rename your program to 110488 to Rev B to Rev C, it'll pull that Rev C from the file name and change it. So less work for you, less typing. Some of the other ones we could do, like I said, we can right click here and we can do edit text, and we'll do modified underscore date time. And again, that'll export when we tell it to. And if you set up all these options here, so it takes you a little bit to create this skeleton program, but every time that you go to write a new program, you're not going to have to do all these steps, which just saves you time, which makes your bosses happy, which makes everybody happy. Some of the other things you can do is we could do text prompts. I was talking about drop-down lists. So we're able to come in here and pick a file. And instead of me saying operator initials, and every time we run the program, you're going to have to type in your operator initial, what we can do is we can go and we can create a drop-down list. The way we create a drop-down list is we'll go into our drop-down list folder. I already have an operators list here, but we'll create a new one. So I'll right click and I'll say new, and I'll do a new text document. And we'll call this op initials. And then inside here, all you'll do is type in your operator initials, or you could do full names. Just doing my team's initials here. And then can save, we'll exit out of here. And then in my inspect, if I go to edit text and I go to pick file, we can do pick list only or drop down list with free entry. So this, you'll only be able to select the initials that I put in, or you'd be able to select the initials or type in your own initials there. So in here, we'll go to my desktop. We'll go to my shared drive. We'll go to microview, drop down list, and select my op initials. And we'll click OK. So the reason that I was talking about file paths and why it's so important is because if that file path ever moves, it's not going to be able to find that text document right there. So having your file paths really organized will be really useful for you. So now when we go to run the program, we'll save it first. Now we're able to select which operator we want to use. So you don't have the operators, you know, typing that in every time you run a program, whatever it might be, the options are there. You can do it everything from what shift you're running. I mean, possibilities are endless, whatever your team might need there. Now, instead of them selecting that drop-down list, if we have them signing in, you would be able to type in that inspect user, and whoever signed in, it'll automatically do that for you. So here in a little while, I'll go through on how to set up users and their permissions. One of the other things I want to talk about was order of taking measurements. So I wanted to bring up this program here that you guys see, you know, the old sample slide that we use as an example a lot. As you guys can see, my labels, my dimensions are way out of order. I have datum B, A over here, datum B. I stay really organized and label everything that I do. So this is my origin of X and Y. So it's my 0, 0 of X and Y, my 0 of Z. And then it's nice to show here, this is where it kind of all collides, and I have my datum A, B, and C. So when we talk about true position at the end of September, having all these origins and datums set up correctly is going to be very, very useful. So if I was programming, the first thing I would do is measure datum A, datum B, and then when I go to measure something, I want the shortest path possible when I'm programming. So I would, if I'm coming here and my, my step, let's say 4, step 4 is this, I know dimension 5 is the closest feature that I have to the last step that I did. So I'm going to go in the shortest route possible around my part and not worry about which bubble is 1, 2, 3, 4. So if I was going to measure the part in order of the numbers on my blueprint, I would be bouncing all over the place on this program. So I'd come down to dim 5, then I would have to jump up to this line for dimension 6, and then come over to 7, then come get an angle. So stay shortest paths possible when we're writing a program, and then when you label them, you're able to reorder them later or whatever might be useful for you, how you guys are reporting on there. So not following the bubbles is really good. If this was a semi-automated program, I'm going to go ahead and delete my recall refsys. So this is a semi-automated program. If I want to run this program, I'm going to have to measure datum A first, which is my first step, and there's 3 F-scan lines. And then my second line is 3 F-scan lines. That's a lot of clicking just to get my program up and running. I want to get my program up and running as quick as possible. So what I normally do, I'm going to do File New, is if you guys remember from previous webinars, I talked about simple and common systems. Here's a sharp edge on here. So if I was going to write a semi-automated program, all I would do real quick is take 2 F-scan lines. I know my image is very blurry, but you guys would do autofocus and adjust your lighting here, right? So I will do an intersection point between those 2 lines because I can see those 2 lines in the same camera window. So real quick, I'm going to be able to take 2 quick lines, set my origin at X, Y, and Z to that point, and skew to the bottom line. Now I can go and take my long edges on this part, line more inputs, and I'm able to come down. And I'm not going to bore you to death with me programming this sample slide, but the whole point here is that I just have to take 2 quick lines, and since my system is right after that intersection point, then it becomes automated. So I put the part on, I find 2 quick lines, and then the program gets running. Don't waste time, measuring the whole line of datum A, whole line of datum B. Set a system that really doesn't matter, and it just gets your program up and running. Then you can go measure your datums and set a new system and label them like I did in the other program. If you don't have 2 sharp corners, go back to that slide in the previous webinar of, circle, circle, line, circle, whatever it might be to get a common, simple system up and running real quick for you. So after I would go measure all my vision tools, like this program here, I would then go get my touch probe. A lot of people ask, well, what if dimension 1 is vision, dimension 2 is touch probe, dimension 3 is vision? Instead of wasting that time having your camera go from vision, go grab the touch probe, measure a feature, put the touch probe back, then go measure vision. Measure everything you can in vision first, and then go get your touch probe. And this is why labeling and all that is super important as you're programming. I've mentioned it time and time again that I'll measure a feature, I'll hit F2, I'll rename it, I'll hit F3, I'll tolerance it, I'll hit F4, and I'll export it, and then I'll move on to the next feature. Just to keep, the production time down on there. Another thing that you can do, a lot of people are asking, and I've showed it off a couple times, is making your program as fast as it possibly can. So I'm going to go ahead and right click, insert here. So this is one way, if you have a semi-automated program, you can make it fully automated. If you right click at your top feature, insert here. I'll insert my recall RESIS. I'll highlight everything from that system down to the next system. I'll right click and I'll set my system to that new system. And always remember, right click, insert at end. And so, since this is a demo version, it's going to go real quick when it measures all this, so don't be surprised by that camera window. Save. Don't you all wish your machine could move that fast? So one of the things that I do at the end of my program is I go to Tools, Auto Generate Drive Points. I'll select all features. So what this is doing is this is any feature that can be measured in the same camera window. So if I come to this circle and I right click on this arc and I say move here. So I have this arc and I have this arc. If I'm able to, I'm going to go ahead and delete these arcs and create new features in here. So if I do a bunch of best edge points around this diameter here, it can see all those features in the camera window in the same spot. It doesn't have to move the camera, but the way that you've probably noticed your machine runs is it'll come take this point, and then it'll come take this point, and then it'll come take those points. But if I go to Tools, Auto Generate Drive Points, and I click All Features, it actually shows me the number of vision tools affected, the previous number of snapshots, so the amount of times the previous number that it had to move to each feature, and the new number of snapshots that it's able to take on there. So it went from 35 moving around to 2. Now that's a little exaggerated, and I think it's because of the demo version, but you'll see that you can save up to 50%. I believe Dan even was programming recently, and he found 80% in runtime reduction. So he brought a program that was almost 2 hours down to, I believe it was a half hour or 15 minutes. It was pretty cool. So these options are here to make your programs run faster. You can either do selected features or you can do all features on there. So if you just want to do this selected feature, you're able to do that option. If you find that you did the auto generate drive points and you don't want, say, dimension 3 to, do the auto generate drive points, maybe a vision tool is failing to measure because it's too large and it's not fitting in the camera window, which sometimes it'll do, you can actually right click it and come down to clear drive point. And then that'll take it out of that auto generate drive points on there. One of the other things I want to talk about to save you guys time is group tolerancing. So instead of individually tolerancing each one of these diameters is the same dimension. So I'm going to highlight all of them. You can click and drag in your schematic window, or if you know which ones they are, you can click and drag in your features list. You can right click tolerances, and you'll notice that you have a bunch of question marks here. So I'm going to type in my nominal, and then I'll type in my tolerance, and I'll close. So it group toleranced all those diameters, so you can save yourself time of individually doing each of one. It also helps you with exporting too. You can group export. So I want all these diameters to export on there, so you're not individually doing each of them. So like I said before, I usually measure one dimension, rename, tolerance, export. If you know you're about to measure 4 dimensions that are the same feature, same tolerances, same exports that you want, you can go ahead and do that to save yourself time there. Another thing that was requested to talk about was outlier rejection. So I measured this diameter here. I come down to my point view. I'm going to open up the large point view for you. And we can actually right click in here and open outlier rejection. The one thing that I want to say before talking about outlier rejection is you really need to discuss as a team and with your customer or supplier what a standard deviation or distance that you're going to eliminate points out of that circle that we measured to report your diameter size, whatever it might be. Some of the uses for outlier rejection that I've seen is that if you know your part has a lot of flash or burrs that are acceptable, but it's throwing off your diameter measurements, you'd be able to do standard deviation and eliminate points in your diameter. So here, if you look, when I eliminated some of those points, it cancels out of that and it takes those out of your best fit circle. So if these were big, you know, burrs or flash, whatever it might be, it eliminates that from your dimension. So that just brought my diameter that was out of tolerance, it brought it into tolerance because that flash and burrs, whatever it might be, were skewing my results on there. A lot of customers ask me, what standard deviation do you recommend putting in here? I don't really like to give an answer because it's up to your team and agreeing with your customer or supplier on what you can eliminate from that part. If you have in one of your notes on your blueprint that flash is acceptable up to 10 thou, maybe you start using that because you want to eliminate anything between, let's say, 0 and 5 thou. You want to eliminate that flash out of there. So if it's just that small, you can eliminate it and not worry about it, but you still want to catch any flash that's above, you know, 5 to 10 thou when you're measuring it, because you want to catch that bad flash there. If there's any questions on outlier rejection, or if you guys have certain diameters or features, whatever it might be, that in process flash is allowed and you want to really dive deep into what the possibilities for this would be, Dan and I are here to help you and give you advice and kind of be able to talk to you and your customer if needed to kind of come to an agreement on what outlier rejection settings you would use. And you can see down here that the original points that were measured was 300. We removed 133 points that was measured with those S-scan arcs and the amount of points that are still remaining. So I still have 167 points around that diameter. So if I was reporting circularity, I would still feel really comfortable with that circularity because I have the points, the amount of points that I would need on there. Yeah, so the options are there. We'd love to help you out with it, but it's one of those things where I want to show you the tools that you have in your toolbox, the options you can do and how it works, but there's no right or wrong advice that I could give you without seeing your parts and that certain feature and the functionality of that specific feature when putting outlier rejection on there. All right, I want to talk about setting up permissions on here. Setting up permissions. If we go to your folder on your computer, we want to find your C drive. Every single computer that's running MicroView will have this file path on here. And this is where you will be able to set up your users and operators. So if I go to my C drive and I go to Programs x86, we'll go find MicroView Corporation. Also, I want to mention that a lot of these file paths are available in your advanced training manual, so you can find them when you get to your machine and you forgot exactly what I said. And also too, when I send out, after this webinar, I'm going to send out a survey and a link to next month's webinar. If you have any questions or you want these file paths, just ask me in the email response and I'll be able to get them to you. But I go to C drive, I go to Program Files x86, I'll go to MicroView Corporation and Inspect for Windows, and then you'll see a ton of files in here. Be very careful clicking around in here. There's a lot of data in here that's very important to your software. but we'll go to configure users, and this window will pop up. This window right here, right now I don't have any users set up, so we can create a new user. But the first thing I want to do is create groups. When you click groups, these three options right here, admin, programmers, and operators, they're default and you can't delete them or change them. But we can create new groups with different permissions. So you can see administrators have permission to run part programs, edit and save, edit part program defaults, settings. They can calibrate the machine. Basically any, trusted user, quality manager. If you're the main programmer, you want to be an admin, so you can change all these kind of things. And you also have the permission to edit the configure users and passwords on here. So we're going to create a new group. We'll call it training group. Now we can select what we want to allow this user group to use. So this is going to be the user group of whoever it might be that, say, like I said, you're the programmer and you have operators, you want to give them specific options and privileges. So I want them to be able to run programs. I want them to be able to edit part program defaults. I don't want them to be able to edit or save part programs, because I don't want them, if I wrote a master program file, I don't want them being able to edit that and save over it. I also want them to be able to, let's see, I don't want them calibrating anything. I want them to be able to calibrate touch probes. So if they're running a program, they'd be able to calibrate touch probes. And then that's about all I want them to do. So they can run programs, they can edit tools in the program itself while it's running. So if maybe, it failed to measure, they can adjust the tool over here, but they can't save. If they move the tool to a different feature, they're not able to save it and ruin your program that you did. So I'll click OK, and then now I can create new users. So I'm going to create myself, and I'm going to assign myself as admin with a password. That's my birthday, by the way. And then I'm going to create a new user, and that new user is Dan. And I'm only going to allow him to do the training group that I did there. And he can have a different password here. Sorry, Dan, I'm forgetting what your birthday is there. We'll call it, that's your password. So I clicked OK. Now the configure users are in there. So now in my program, if I had that skeleton program here, there's a program that I did earlier. So if I come in here, instead of operator initials, I can edit text and I can type in inspec _ user, and I'm going to file save. I'm going to exit out of inspec, go back to desktop. I'm going to open up, let's go ahead and find inspec. So now when inspec opens, you can log in as Dustin or Dan. And when we log in as Dan, now that skeleton program that we wrote earlier, when it exports that skeleton program, the operator will be the inspec user. And since Dan signed in to inspec, it's going to export that and tell me who that was on there. All right, let's go ahead and come back here. So that was a lot of information, just kind of little random things this month. I'm going to skip through all these slides while I'm talking. We decided this webinar just kind of throw a bunch of random things that can kind of help your inspection process and your programs get up and running faster, how to make them more automated, do less typing, these little codes here that you can, be able to have more information and know who's doing what in your programs better for you. Outlier rejection, I'm sure a lot of questions are going to pop up after you guys get off about outlier rejection, what you guys can do. We're here to help. Feel free to give us an email. A couple other things I want to talk about, I was talking about earlier, is our inspection department. Here's a little like card that says all of our capabilities, but not limited to just these capabilities. We do third-party first article inspection, PPAPs, anything that you might need. Like I said earlier, if you're not able to handle the project because of time constraints or whatever it might be, or machine size, send us the blueprint and we can quote it out for you. Mention this webinar and we'll give you special pricing. Next week, I mentioned we have a bonus free webinar. It's going to be about a half hour just talking about touch probe styli options, building a new touch probe in spec, and which force modules to use. I'm hoping this is going to spur up some ideas for you guys, that you guys might need some new styli or building a styli library, so you have many different options, so you can take the best measurements with your touch probe across the board of your part. And then, as always, here's a bunch of emails that you can contact us at for any questions. Next month, can't believe it's September already. Next month, I believe it's the last week of September, we're going to be going through step by step on how to measure true position and the steps that you need to take. So if you don't get the email today or see the link or able to click the link, email training@atiquality.com and we'll be able to get you the link. Or you could go to atiquality.com and on the left side you'll see an events page, and any events that I am hosting or Dan's hosting or anybody in our organization is hosting, you'll see there, and the sign up options there. So yeah, that's it for today. Finishing up about 5 minutes early so you guys can get back to programming and running your parts. Again, please reach out to us with any questions, anything that you might need. And I saw somebody mention in the chat that they have parts that they'd be willing to send to us so we can do examples on true position. So if you are able to send us parts and I can use it as real life examples of true position in the blueprint, please contact us and we'll get it rolling. So thanks for joining in today. Hopefully you sign up for next week's touch probe webinar, but definitely sign up for the end of the month in September, the true position webinar. So thanks and have a great rest of your week.